think so, yes.
Do we have to do a test? Okay. Steve's member 7 minute.
Yay!
Can we get the Quasar icon of my presentation ready?
It's right there. Oops. Right there.
What's the new pointer?
So let me forward and backwards.
And
And the laser's right there.
I'm Steve Ruiz. I was an engineer, aerospace engineer out here at NASA for 31 years. Retired in '99. I've been interested in astronomy since I was 15. It takes me back a long ways. And about 25 years ago, I began to notice that there are still a lot of mysteries regarding the universe. A lot of missing puzzle pieces, a lot of conundrums, a lot of mysteries. And I began to make a list of them. And began to think about solutions for some of them. In May, I gave a speech here on black holes and why we can't see them. Some of you may have been here. Today I'd like to talk about some things that I made up a question about. I quit, not that I quit, but in addition to the mysteries that I read about, I began to ask my own questions, like, why are there no questions? Quasar is younger than 13 billion years. As we all know, the universe is only 13.7 billion years. And it seems that there's about 40 quasars that are known. And they all seem to have been created at the beginning of right after the Big Bang. And why are there no younger quasars? Why aren't there any newer, close-by quasars? Why did they quit being created after just a billion years? It seems no one has asked that question. I've never seen it asked anywhere. But I asked myself, and I tried to answer my own question. Some facts. It's kind of hard to read them from here, but identified in the early 60s, it's still considered some of the most mysterious objects in the universe. Most are thought to be at the center of proto-galaxies surrounding a black hole. And I stress the word thought to be. Luminosity could be thousands of times that of the entire Milky Way. Among the oldest objects ever observed with the highest redshifts, and so far found only at the most distant edges of the universe. Why is that? No one seems to have gotten past that question. Here's some typical quasars. It didn't take long to notice that they're at the center of an amorphous, fuzzy cloud of material. There are no spiral arms, and at the lower part, oops, this is the spectrum of hydrogen in the lab, the emission spectrum and the absorption spectrum. And here's the spectrum of a typical quasar. It didn't take much to see the similarity between the spectrum of a quasar and the spectrum of hydrogen. To me, it tells you that quasars are made of mostly hydrogen. Here's some spectrum of some other quasars. You can see the similarities of the hydrogen lines. They're all peak at hydrogen. So that tells me that it's really hard to read the thing. It appears that quasars are composed mostly. I'll let you read it as I talk. Well, maybe I should read it too. But yeah, quasars. It tells me that quasars were made of what was most abundant at the beginning of the universe, which is hydrogen. Most images show the quasars have little or no spin, and its host galaxy is an amorphous, ill-defined structure, like I said. Some of the images of quasars show a sort of an arm, but they're thought to be jets. Okay, here's the really important part. As the universe evolved and exploding stars, supernovas, spewed the heavier elements into space, the next generations of would-be quasars had a different diet. Some of the heavier elements, like carbon, oxygen, and iron. And the accretion of this newer material at greater mass may have imparted angular momentum or spin to the newer objects. So why aren't there any newer, closer quasars? The question again. I believe that this spin created the frame-dragging effect which distorts the surrounding space-time metric and keeps us from observing them, which is why we call them black holes. This diagram shows frame dragging. Here's a black hole, and we're looking at down the north pole of the black hole. What I did is I imagined myself turning this graphic 90 degrees and looking at the equator of the black hole. I think as you do that, that object disappears. And that's because space-time is being twisted around to a point. If this is your line of, say you're over here, and this is your line of sight, this is your column of observation, you would expect to see something there, but you can't because your line of sight is being pulled around to the limb and pinched off to a point. And that's what happens to a black, that's why we can't see a black hole. I think black holes are would-be quasars that are invisible to us because of the spin imparted by the increased mass of the material that was spit out by supernovas. Yeah, these sentences are self-descriptive. So question number 2, were you somehow able to suddenly stop a supermassive spinning black hole from spinning? Of what should you be first be certain? You're wearing welder's gloves, if you're doing it by hand. This is the funny part of the whole thing. Your video camera's ready, you brought marshmallows, or you're in another galaxy far, far away. I believe that if you would instantly unleash or stop a black hole, you'd have a quasar. That's just my answer to why there are no newer quasars that became black holes that were invisible. I want to thank Doug Holland for putting my first presentation back in May together, black holes, and this presentation. He's done a great job of putting the slides together, and I thank you for listening.